180 minus 46. Now, why is that? Remind me. Because they are supplementary. They are supplementary. So what do we call this angle, the 46-degree angle? What is that angle called? There's Daniel. What is that one called? It's on the outside of the circle. It's got a special type of name. Does anyone remember? See, Rios forgot, but does anyone else remember? It starts with a C. Nope, not corresponding. I have some ghosts in this classroom. It does have a common endpoint, but that's not the official name for that type of angle. All right, I know 2 people know the answer. You can reveal it now, guys. There it is, circumscribed. We have a circumscribed angle, circumscribed. What type of angle is angle O? That one's central, good. See, they all start with C, so they can be a little tricky to remember, but we have circumscribed angle, central angle, and we know that a circumscribed angle is going to be supplementary to the central angle. So we just subtract, like Perla said before, we're going to subtract from 180. So 180 minus 46, what does that give me? 134. 134 degrees. Questions on that one? No questions? Okay. That's the central angle. Okay, and then on example B, which angle are they giving us now? What is this angle called? There we go. Good, Emily. This is my inscribed angle. And we're looking for angle A. So to get there, we have to take a couple of different steps because what do I have to find first? The O, the central angle. And what's the relationship between the inscribed angle and the central angle? Times 2. Good. So how much is angle O, the central angle? Good. So the central angle is 130. 65 plus 65 gives me 130 times 2. And then from there, how do I find the last one? So you got 50 degrees. How'd you get that? Again, subtracting from 180. So angle A, we end up with 50 degrees. Questions on this whole problem? So this is kind of a big review of everything we learned last week. Any questions? If you're not sure how I got any of those numbers, now is your chance. You had a question? What did you forget? Oh, how was everyone's weekend? That's a good question. Anyone do anything fun or cool or different or interesting? Why, Alejandro? What happened? Yeah, I'm sorry to hear that too. Jalen went to a gun range? Nothing happened, Alejandro? Is that why you hated it? Because it was boring? No? Well, if it's something deeper than that, we don't really need to discuss it, but I'm sorry that you had a bad weekend and I hope the next one is better. Yeah. Yeah, we don't need to bring it up right now. Anyone else do anything interesting or different or cool? Jalen's doing scary things on his weekend. Okay. No one else? That's it? All right. So today we are continuing with circles as we have been, but I just want to let everyone know we will have a test coming up. I know it feels like we just took one, but right before spring break, it's going to be a test just on circles, everything we've been talking about to do with circles. So, I believe this is topic 7. Yeah, topic 7, assessment. Mark your calendars. It's going to be March 24th and 25th, right before spring break. It's the Wednesday and the Thursday, right before spring break, which means if you are, I don't know, if you're planning on going on spring break early or you don't know if you're going to be here on those days, then you're going to have to take it earlier. Or you might have to take it all in one day rather than splitting it up. So just be aware and have that date marked in your calendars. March 24th and 25th is going to be our topic 7 assessment. So that's all about circles. Everything we've learned about circles. Any questions on that? Okay. All right. So today we're going to begin, like I said, we're kind of moving on with circles. This time we're going to be looking at segments and angle relationships, which means we're going to be talking about chords today. So I have a link for everybody. Give me one moment. And I'll send it in the chat. And so when you click on that link, I want everyone to kind of play around with it like we did last time. Play around with it for a little while. And then see if you can answer the question that I have below. All right, go ahead and click on that link. I'll give you guys about 3-4 minutes to play around for a little while, and then we'll come back. And if you're starting to notice anything, you can feel free to put it in the chat, either in public or privately. Just about one more minute, guys. All right, start heading back, start heading back. And I'm sharing my screen. I'm on the same exact page, and I just want to do it together now. So first of all, so hopefully everyone's back on Zoom now, taking a look at what I have here. So I clicked these two boxes because they kind of help you to see what's going on. But basically, I have two intersecting chords. I have D, E, and I have C, B. Can anyone just remind me really quickly, what is a chord? What is a chord? A line that goes through a circle twice. So the end points are on the circle, right? And okay, and Jalen just said it privately, but I'm going to say what he told me because it's also true. It does not pass through the center. If it's going to pass through the center, what would that be called? A diameter, good. So a diameter is like a special type of chord, but most chords are not going to pass through the center. They can be pretty much anywhere else on the circle, but typically they don't pass through the center because then I would just call it a diameter. Okay, now they're intersecting. This only works when they're intersecting. Okay, if I kind of draw it this way, it's not really going to work anymore. So I'm making sure that they intersect. And now let's take a look. So notice over here, these numbers have been changing all along. But what always happens, no matter where this is located, what's true? I'm just moving it around. What do you notice about those numbers right here? Good, I'm seeing it in the chat privately. No matter where I go, those two equations remain equal. Right? So here, for example, both of them are equal to 40.93. Now, what are those equations? Let's take a look. So I have CF times BF, CF times BF. So if this is a whole chord, if CB is the chord, C to the place where they intersect times B to the place where they intersect equals 40.93. And on the other side, if DE is the whole chord, DF times EF is also 40.93. So this is called the chord-chord product theorem. And we're going to talk about it a little bit more in depth. So let me switch back. All right. So the question was, what is true of the product of intersecting chords of a circle? And what we can say is that the product of one endpoint to the intersecting point and the other endpoint to the intersecting point will be the same for both chords. So you can go ahead and write that down. The product of one endpoint to the intersecting point and the other endpoint to the intersecting point will be the same for both chords. That is the chord-chord product theorem. I'll write that down as well. All right, take a couple of moments, write that down. Okay, anyone still writing? All right. So now let's go ahead and take a look at the theorem. And this is the way it's written in your textbooks, but since we pretty much already wrote it down, the most important thing is to just have the actual diagram. So this diagram is very useful because now we can actually see what it's talking about. AE times EB will be equal to CE times ED. All right, any questions? Anybody still writing? Awesome. So now let's do a couple problems. So because of this theorem, we can do a little bit of math to see if we can figure out the length of some missing side lengths. So here are two examples. Let's start with the first one. So first thing is we're just going to set up the equation the way that we usually do. So we know that CE times ED is equal to AE times EB. And now I'm going to fill in all of my blanks. So CE, that's 6. ED, that's 2. AE, we don't know. EB is 3. And now I simplify a little bit. So 12 is equal to 3x. What do I do to both sides? What do I do to both sides? If you already know, I know, but go ahead and put it in the chat publicly so you can help your fellow student friends out, your classmates. No, I only have 2 students in this whole class that know how to solve this equation. And they're both giving it to me privately. Tyrone, what do I do to both sides? Oh, okay. So you're all just doing it in your head and you're not helping your friends out. Okay, okay, I see how it is. And 12 divided by 3 gives me 4. Questions on this? It's pretty simple. It's pretty simple, but let's go ahead and actually answer the whole question because it says you have to find x and then find the length of each chord. So now let's find the full length of each chord. So how long is AB? AB would be how much? 7. Yep, so you just add. Since x is 4, we're just going to add those lengths together. So 4 plus 3 is 7, and then how long is CD? Yeah, you had it, Tyrone. CD is 8. Okay, we're adding, not multiplying, right? Because if I know if this is 4 inches and this is 6 inches, I put it together, I get 10 inches. We're just adding. We're not multiplying. Questions on that? Let's do number 2 real quick. Number 2. All right, same idea. We're just setting up our equation first. So I know that, I'll do it here, kg times gi is equal to hg times gj. Kg is 6, gi we don't know. This is 9, this is 8. 6x equals 9 times 8 is 72. We divide by 6. X is equal to 12. Good, Rios. And now let's just find the full lengths. So how long is HJ? Good, 17. And then the other one, KI. KI would be 18. Tyrone, yes. What? They're both 1 off. They are. Now, we don't know if that's always going to be the case, though. They just happen to be in this case, but that's not necessarily a pattern. So you notice that, and that's good that you noticed it, but it's not necessarily always going to be that way. Okay? Cool, cool. Any questions? Awesome. All right, let's kick it up a notch, as always. So this one's a little bit more challenging, obviously, right? But we're still going to follow the same steps. Set up the equation, fill in the blanks, and do the math. Starting with my equation. So I know JL times LK is equal to ML times L. Oops, I don't have a letter here, so let's call this N. LN. Now I'm going to just fill everything in. So JL is X. LK is X plus 4. ML is X plus 2. And Ln is X plus 1. So this should look pretty familiar if you're thinking about algebra. We're thinking of, in terms of algebra, what is something I'm going to have to do here? We'll have to combine like terms, but I can't really do that yet because I have parentheses. So parentheses are telling me to do something else first. What would that be? Distribute. Okay, good. So on the left side, I can distribute. So quickly, let's go ahead and do that. What's x times x? X squared, good. What's x times 4? 4x, beautiful. Okay, now on the right side, can't really distribute, but what's that thing that we can do instead? It has a special name. Factoring is the opposite of what I'm thinking of, Emily. There it is, FOIL. Yeah, we're gonna FOIL. I'm multiplying 2 binomials, so I know I'm gonna have to FOIL. So let's quickly review how to do that. So FOIL, first times first, x times x. What do I get? X squared. Good, then outer. So the outside terms, x times 1, I get x. Inner, inside, like Tyrone said, 2 times x. I get 2x. And then last, but not least, 2 times 1. Like Alejandro said, you get 2. Nice. Good job, guys. See? All these things, they're in there somewhere. They're in there somewhere. Does anyone have questions on the foiling or the distributing? Awesome. Okay. Well, now I have this crazy equation. First thing we want to do is like Alejandro said, we're going to combine like terms. I have x and I have 2x. That's going to be 3x. And now I can start to solve the equation using inverse operations. We're going to move things around. So Alejandro said minus 3x. Let's do it. Minus 3x. So if I subtract 3x on the right side, I'm going to do it as well on the left side. 4 minus 3, I get 1. Oops, equals x squared plus 2. And then Rio says, now we can subtract the x squared. That sounds good to me as well. We subtract it. So minus x squared on the right side, minus x squared on the left side. And what happens is they cancel out. So they cancel out on the right side, they cancel out on the left side, and I am left with x equals 2. So I rushed through that a little bit, but well done, Rios. He was doing it right alongside. Did anyone get lost or confused or need to explain anything? Okay, is that my final answer? No, what do I have to do now? What am I actually finding? Yeah, because what is this question asking? It's asking for JK for this whole thing. How long is JK? So JK is x plus 4. So 2 plus 2 plus 4, 4 plus 4, I get 8. Cool, any questions? And mn, yeah, mn would be 7, right? Yeah, 2 plus 2 is 4, plus 2 is 6, plus 1 is 7. Nice. All right. Questions, comments, concerns, anything? Okay. Let's try another similar situation. A little bit easier, I would say, but go ahead and try this one on your own. I'll put in a poll. Let's see how we do. KZ, that would be, yeah. So KL is 2, and then LZ is 3x minus 2. All right, 2 people have put their answers in. Keep working, take a couple more minutes, 1 or 2 more minutes. Ooh, interesting. Very, very interesting. Take about, I see 4 people have answered. There's 3 remaining, so take 1 more minute. Very interesting indeed. 30 seconds. Interesting. Okay. 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. So I have 2 ghosts here today, 2 ghosts who did not answer, but of those who did answer, let me show you the results. Interesting, isn't it? Okay. Well, let's find out. Let's find out if this is correct. All right, so first thing is first, I'm going to set up my equation. Can somebody set it up for me just using the lengths? Don't put numbers in yet. What are the lengths? So set it up. So using the letters, like the segments, the line segments. Okay, before that, I know what you're doing, but before that, it would be KL times LZ is equal to WL times LP. And then plugging in what Perla has, 2 times 3x minus 2 is equal to x times 5. Okay, so I'm just writing in everything that I have. Well, on the left side, I'm going to distribute. Distributing all the way across. If you didn't go all the way, you probably got the wrong answer for x. So we get 6x minus 4 equals 5x. What should I do now to both sides? We can subtract 6x, good. 5 minus 6, I get -1. But what should I do to both sides now? Good. If I divide both sides by -1, I know that x equals 4. Go ahead and take a look. Be very careful. Take a look at everything that I wrote down because clearly we do not understand how to do this. I only had one person get it right. So I need everyone to take a moment and look carefully. Make sure that you understand. Okay, anybody know if you messed up, if you did something wrong, make sure you know what you did wrong. Does anyone not see what they did wrong? Okay, and now we have to find KZ. We're looking for KZ. Well, KZ is 2 times 3x minus 2. Oh, plus 3x minus 2. I'm sorry. Plus. 2 plus 3x minus 2. We add it together. So when I plug in my 4, this is 2 plus 12 minus 2. So I get 12. Answer choice D. Check it out. See if you have any questions. Anybody questions? Going once. Going twice. Cool. Let's do one more then. Same sort of situation. I'm gonna do another poll. Try your best not to X out of it so that you can put your answer in. Go ahead and try it out.
It's easy.
Mm-hmm. Okay, Tyrone, thank you for letting us know. Yeah, apparently you can get the poll back. So look around. If you lose it, look around. Okay, so far I have 2 answers in. Keep working. Give you guys another 30 seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Okay, another interesting situation. Here's what we got. So
I
A
don't think
and
it's
B,
B.
A and B are tied. D, only one person responded that. So this one's challenging.
Doesn't make sense.
This one's challenging. Which one doesn't make sense?
C and D.
C and D. Okay. Now I have a guess. I think I know how Daniel did it because I know you by now, Daniel, and I know exactly how you treat these problems. Did you plug in the answers to see which one makes sense?
Yes, I use 2 ways actually. So first, I plugged in the X.
Mm-hmm.
The second way, I just realized that -2 doesn't matter which direction it goes in because it's just a line. It's just a line. So
Okay.
-2 is still the same size as normal 2.
Okay. So half of what you said is correct. Half of what you said is correct, and we'll talk about it. So I'm gonna label these so that we can talk about them. Okay. So there's one way. There's one way to do it, which in my opinion is the more, if you did it this way, you are more algebraically inclined and you enjoy solving things algebraically. I can probably guess that Emily did it that way, and I think maybe Perla tried to do it that way, but then she switched her mind and did it a different way. But let's take a look. If you do it algebraically, what's going to happen is you set up your equation, right? So this would be AF times FB equals DF times FE. So x times x equals 2 times 2x plus 6. And you go ahead and you do what you got to do. So x times x, that's x squared. Distributing, I get 4x plus 12. And now I have this equation. What type of equation is this based on what you see? It's algebraic, but look at the exponents. What type of equation is this? Starts with a Q. Yeah, I'm seeing it in the chat. This is quadratic because it's got an exponent of 2. And that exponent is not going to cancel out. Like if you look at this problem, the first one we did, I had x squared on the left side and I also had an x squared on the right side. So later on, what Alejandro told us to do was to subtract that x squared and it was able to be canceled out. But in this case, I can't cancel it out. We can't cancel it out. So what we can do though, is I'm just going to subtract what's on the right side so that I can move it to the left side. So I'm subtracting it on both sides, and I end up with x squared minus 4x minus 12 equals 0. Now it's in standard form, and in order to find the value of x, I'm going to factor. So this is where we're going to factor. This is a big review of quadratic functions. We're looking for the solutions, so we're just going to factor this trinomial. So that means that I have to fill in the blanks. What numbers go into those blanks when we factor? Remember, they have to add up to -4, add up to -4, and multiply to make -12. What are my two magic numbers? What two numbers add up to -4 and multiply to make -12? Yeah, it's got to be two numbers. Add up to -4, multiply to make -12. There we go. -6 and +2. -6 times +2 is -12. -6 plus 2 is -4. So here we go. So -6 and +2. And since those are my factors, what are my solutions? Those are my factors. So remember, when it's in factored form, what are the solutions going to be? It's the opposite of what we see. So what are my two solutions? +6 and -2. +6 and -2. Those are my two solutions. Now, looking at the answer choices, I see both of those options, but which one is right? Well, now we got to think about the fact that this is a real world scenario. I mean, it's not really a real world scenario, but when you're measuring things in geometry and things have length, things have measurements, do negative numbers make sense? They don't. If I'm measuring the length of this notebook, I'm going to pull out my ruler, I'm going to measure it, and I'm going to get a positive number. You're not going to get a negative number. Because in the real world, there's two things that are always positive: time and distance. Okay, because time, you can't go back in time, and distance, you can't have a negative distance. That doesn't make sense in the real world. So for that reason, even though both of those numbers technically work, the right answer is D, not A. So only one person got it right. So again, see, this is what happens with these problems. You guys think it's going to be easy, but as soon as it becomes a little more complicated, a lot of y'all, you tap out, and you can't be tapping out on me like that. Especially when you guys are doing really well in geometry, which means I know everybody here is going to pass their geometry EOC without a problem. But what comes next is algebra 2. And algebra 2 gets a lot harder than what you learned in algebra 1. So that's why I'm bringing back these types of problems, because I need to make sure that we're still practicing those skills, that maybe you're not going to be tested on those skills right now, but you will be next year. And I want to keep those things fresh in our minds. So how do we feel about this problem? Questions? I know you have them. I will not move on until I get at least one question. I'm not moving on till I get at least one question. So think about anything on this page that you're not so sure about. Ask it now. I'll stay here for the whole rest of class. I promise you that. I'll stay on this entire slide. Okay, thank you. My anonymous question asker is, how do I go from this step to that step on factored form? Factored form, super easy. Super easy, because all you do when you're in factored form is you split it up and set it equal to 0. So I skipped a step, right? I didn't write this part down because it's easy to do without writing it down. So technically what happened is we set it equal to 0, and then you solve for x. So on the left side, I had to add 6 to both sides, which is what gives me x equals positive 6. And on the right side, I have to subtract 2 from both sides. So that's how I got x equals negative 2. But you can basically look at the factored form, and the negative 6 becomes positive 6, and then the positive 2 becomes negative 2. So with factored form, if you forget how to do it, just remember, you split each part of it, set it equal to 0, and then solve for x to get your answers. So that's how I ended up with positive 6 and negative 2. And then someone else asked me, in real world problems, can you rule out negative numbers? Basically, yes. Now, obviously, I never want to say that it's going to be 100% always true, but yes, if the question is asking how many feet did the ball travel, how much money did he spend, how much time was he at the basketball game, whatever. If it's asking you about real world objects or real world concepts like time and distance, negative answers are not going to make any sense, so you can cross those out. And then one last question, well, not the last question, but one more question I got is, how do you go from standard form to factored form. So the quick way to remember it, the step that I kind of skipped over here, you think of two magic numbers, m plus n have to add up to -4, and m times n have to multiply to make -12. So the middle term, the b, is what they have to add up to, and the c is what they have to multiply to. And in our case, Perla noticed that +2 and -6 are my magic numbers because those two numbers add up to -4 and they multiply to make -12. So that's where we got -6 and +2. And then you just pop them into your factored form. That's all you do after that. You just pop them right in. Fill in those blanks. Okay, good questions. Anything else? All right, cool. One last one. Let's do this one together. Now, the answer choices are the same. I just realized that. But let's see if we get something different. We'll do this one together because it is similar. We can already tell we're gonna have something to do with quadratic formula because I already see an x squared. But let's see what happens. So A, B, C, D, and F. AF times FB equals CF times FD. So x plus 1 times 2x plus 6 equals x squared plus 19 times 2. So I filled in my blanks, and I bet most of you already know what to do now. What do I have to do on the left side? On the left side. Good, I'm seeing a couple people sending it to me. On the left side, I'm multiplying two binomials, so I'm going to have to FOIL. So I get 2x times x, that's 2x squared. X times 6, that's 6x. 1 times 2x, that's 2x. And then 1 times 6, that's 6. Now on the right side, am I foiling or something else? What do I do on the right side? Good, I just distribute. Kind of backwards, but it's still distribution. 2 times x squared, I get 2x squared. 2 times 19, what is that, 38? 38. Okay, so what do you guys notice that's different about this problem? Actually, yeah, let me combine like terms and then we'll talk about it. So I'm going to combine these two, 6x and 2x. I'm running out of space, so I'll do it down here. 6 plus 2 gives me 8. So think about the first problem we did together, where we had an exponent of 2, and then think about the previous example we just did. What's happening here that didn't happen in the previous problem? Yeah, both sides of the equation have the same term. Both of them have the same term. So what happens if I subtract it from the right side? they both cancel out, right? So if I subtract it over here and I subtract it over there, it's going to cancel out completely. So this is actually easier than the previous problem. So go from here, get the answer. 8x plus 6 equals 38. Everybody here can figure it out on the final answer. Take like 30 seconds. If you have an answer, send it in the chat. All right, oops, all right. And simple from here to the end. We just gotta do a couple steps. Subtract 6 from both sides, I get 8x equals 32. Divide by 8 on both sides, I get x equals 4. So answer choice B is my answer. And like I said, in this case, it started off looking way harder, right? We had to FOIL, we had to distribute, and then I had this whole thing on this whole equation that looked really confusing and really complicated. But we were able to cancel out the quadratic term. And because of that, it became actually kind of easy. So don't be afraid of these. Sometimes you're going to get a quadratic formula, but in some cases, that quadratic formula can cancel out. And in other cases like this one, you might have to factor it a little bit to get your final answer. So any questions on this one? All right. Okay, so we know that this is a theorem, but why is it a theorem? So we're going to look at another, let me send the link. Give me a second to copy it. All right, go ahead, click on it. Take, again, another like 2-3 minutes to work through it and play around with it. And on this one, there's some questions on the bottom. So if you scroll down a little bit, you'll see that there's like a couple of questions underneath. And I want you to try those questions out. So play around with it, see if we can answer those questions, and then we'll do it together. Take about 1 more minute, and remember, look down at the questions. If you don't know all the answers, that's fine, but just spend a little moment seeing if you can figure out those answers. Alrighty, so let's go ahead and do these together now. So head back over to your Zoom screen. And I'm on the same page. And let's see what happens, right? So I can play around with this circle. I can make it bigger, I can make it smaller. I like it right here is good. Okay, and let me make this really, really obvious. So here's my two intersecting chords, right? And we already know because we just did it, that the equation would be that C times D is equal to A times B. That's the chord-chord product theorem. We already know that. C times D is equal to A times B. But let's figure out why. Why is that true? So I'm going to slide this and I'm going to take it slow. But the first thing is they make this triangle. Okay? So here's an angle. And immediately after that, they show these two angles and they've highlighted something. And that something is really important because I have this pink angle and this pink arc. What do we know about the pink angle and the pink arc? Okay, I see somebody wrote on the board already, but what pink and blue angles, that's not quite what I'm asking yet. I'm just asking, just look at the pink angle and then the pink arc. And what do we know about it? Hmm? What do I know? Again, I'm asking, this is the same question. What do we know about the pink angle and this pink arc, which they've highlighted in the same color? They did that for a reason. What is the relationship between the pink angle and the pink arc? Anyone? No, nobody remembers at all what we learned about last week? No one? So, Rios, I'm talking about the pink angle, the pink one, and the pink arc. What do we know about it? No, that's not what I'm asking. Okay, Tyrone, yes, this is an inscribed angle. What about the arc? Y'all, say things on public. You're not helping people out by keeping it on private. I'm getting a little annoyed at this class right now. Okay, the arc is 2 times the angle. Same thing with the blue one. This is an inscribed angle, and here is the corresponding arc. And so the inscribed angle times 2 is going to be the length of the arc, the degrees of the arc. So we know we already have that highlighted. Then I keep going. They make another triangle. And what do you know? Here we have congruent angles. Now, how do I know that they're congruent? Other than obviously we saw it with our eyes, but this angle corresponds to the pink arc, and if you trace it back, so does the other pink angle. So both of these angles are congruent because both of these angles go to that arc. Now on this opposite end of it, the blue angle is congruent as well for the same reason. This blue angle goes to this big blue arc, and this blue angle also goes to this big blue arc. And it's a little easier to see it when if I highlight, let me see if I got the right colors. Okay. Notice here's one part of the angle, here's the other part of the angle. So if you kind of notice, let me make that a little bit thicker. Okay, so see how it touches the angle at the same exact spot? Right here and right there. Right, so that's my arc. This whole thing, that's my arc. And let me go back, and the same thing happens over here with this blue angle. So here and here. It touches the same 2 points, right? Which make up that big arc. So that's how I can set up that relationship, that these angles are congruent to each other. So now let's go ahead and answer these questions. So what did we say? What do we know about the measure of the pink angles? Anyone? What do we know about the measure of the pink angles? They're congruent. So careful with your words. They might be corresponding, but we don't know that yet. Okay, so we'll get to that. But we do know that they are congruent. And why was that? How do we know that they are congruent? Why is it true? Good. Both pink angles intersect at the same arc. You can say it that way. Cool. And then same thing with the blue angles. The blue angles are congruent because they intersect the same arc. Okay, so what can we conclude about the two triangles? They have two pairs of congruent angles. So what do we know about them? What are they? They have two pairs of congruent angles. Good, you got it, Tyrone. They are similar. How do we know what's that theorem? If there's two pairs of congruent angles, that's the AA, careful with your words, that's the AA similarity theorem. Yeah, similarity. Okay, so now let's fill that in. Oops. Let's check. Cool. Now we're going to write a relationship between the lengths, A, B, C, and D. Okay. So since I know that they're similar, I can set up a proportion. Think about what we know about proportions. Okay? Because we can set up a proportion between these two triangles using the side lengths. See if we can fill in the blanks. So I'm gonna start with one of these blanks, and then I want to see if we can all fill them in. I'll start with A. So I'm putting A there. Now go ahead and use the annotation tool and see if we can fill in the remaining letters. Good. A over C, short over short side, or small over small side, is equal to what? D. Good. Over B. Good. So A over C, right? Corresponding sides. A is corresponding to C. So A over C is going to be equal to D over B. And now, what do we always do with proportions? What is that called? If I was going to solve this, what would they? Yeah, good, Tyrone. I'm going to cross multiply. Well, when I cross multiply, I'm going to be left with the following equation. Cross multiplication, A times B, I get A, oops, hold on, there we go. I get A, B is equal to C, D. And what do you know? A times B is equal to C times D. That is our triangle, that is our chord-chord product theorem. That's where it comes from. That is exactly why this equation, which we started out with, right? That's the first thing we talked about today was this equation. The reason it's true is all comes down, it all comes back to triangle similarity. So A times B is equal to C times D. How do we feel about that? Any questions on that? We kind of did a little bit of a proof. How do we feel about that? Surprise proof. That is true. That is what we did. So that's, yeah, those are the last two problems on that. So any questions on this? Think about it for a little bit. Look through it, make sure that we understand. Now it's important to know where these theorems come from, right? Don't just take it for granted. If I tell you a formula, it might be nice to look at and it might be really useful, but really understanding why it works is more important, way more important. So, no questions? No? Okay. So, homework-wise, I'm a little frustrated because Khan Academy doesn't have good problems about this topic, unfortunately. It's usually like 99% of the time, Khan Academy is great, but right now it just doesn't have the right type of questions. And I was looking through it and I was trying to find anything that can work, but I really wasn't finding anything. So I don't really have homework. I know, like, you should be pretty happy about this. The fact that you don't have homework, you should be pretty happy about that. But those of you who are missing assignments, because I'm looking and there's still some assignments out there that a couple of you guys just haven't completed yet, make sure you get those done because marking period is ending pretty soon. And the sooner you get that done, the sooner I can update your grade book and you can have the grade that you deserve. So, any questions on what we learned today? All right, we'll continue working tomorrow. And like I said, topic test is at the end of next week. So this week we'll continue to work, but also start a little bit of review of what we learned last week. Cool, that is all for today, everybody. Have a nice day.